Welcome to a session on Graham equations of parallel and perpendicular lines. I'm going to use this line here as an example. Now the first thing I want to look at is the gradient of this. And I'm going to do it a couple of ways just to show you how it works. I'm going to pick a couple of points, one up here, and one, that one will do. Those 2 points. Just to show you how we can work out what the gradient is. This point is 4, 5. And this one is 2, 1. Okay, now let's have a look at the first number of the two. We've got this one on 2 and this one's 4. From 2 to 4, that's the distance of 2. Well, that's our run. The first numbers give you the run. 2 to 4, distance of 2, that's the run. Second numbers give you the rise. 1 to 5 is 4. So the rise equals 4. And because the line's going that way up, the rise is plus. So that's good. Rise over run equals 4 over 2, which equals 2. That's our gradient. And one other way to show you the gradient is to put a line there, a dot there. And that one is 3, 3. Just to show you the gradient in a different way. Now we've got our first numbers are going up by 1s, 2 to 3 to 4. Every time this number goes up by 1, this number goes up by 2s each time. And that's the gradient. If that goes up by 1 and that's going up by 2, then the gradient has got to be 2. We now can put this into an equation, because equations are just simply a way to explain the relationship of all these points. And we start with the gradient. But we need the rest of it. And the rest of this equation comes from here, where it crosses the y-axis. So this y-axis, where the line touches it, is at -3. So that's what we'll put there. And that's the equation of our line. Y equals 2x minus 3. Now I'm going to put that up here. And we're going to refer to that a lot. That's the equation of that line. Okay. Now let's get rid of everything else to show you parallel and perpendicular lines. So we're asked to find the equation of a line parallel to this one, so yep, parallel to this one, and with the y-intercept of 3. That's right there. So it's going to look like this. Parallel to that one, going through there. Now parallel, just to help us remember, is same gradient. That makes it parallel, the same slope. So we can start it with the same way as this, y equals 2x. That straight away makes it parallel. same gradient. But this time, the rest of it is different because it's crossing over the y-axis at +3 this time. So that's the equation of this line I've just drawn here. Y equals 2x like the other line, but instead of -3, it's 2x plus 3. So that's the answer to that one. Now what if then you're asked to find the equation of a line parallel, but it's going through a point. And I'll just take this one away. We're going to go through a point, and we'll make that point this one. Going through a point, what's that point? -2, 4. So what happens then? So what we do is we start the equation the same way because it's parallel. And we don't know the rest. So we put that. That's what we've got to work out. So it's going to be up here somewhere because parallel is going to go that way. So it's going to be up past 6 somewhere. But let's work it out for sure. So when you're going through a point, you sub in. Now let's sub the values into here. So y first, that's 4. And x is -2. So 2 times -2 plus b. So now all we've got is numbers, 2 times, yep, and numbers and the b. So what's that? Simplified. 4 equals 2 times -2 is -4 plus b. Now we're getting closer, but now we have to get rid of this -4 from here. So we're going to add 4 plus 4. That'll get rid of the -4 there. So 4 plus 4 is 8. And -4 plus 4 is nothing. And what left is b. Our b is our 8. Okay, so the equation is, where did I start it? Up here. Okay, I'll put it next to it. Y equals 2x, like we started before. And now we know what our b is, plus 8. So it's going 5, 6, 7 up here somewhere. Now that's the equation of lines parallel, where you work it out through y-intercept or through a particular point. Now I'll have a look at a couple of perpendiculars. Now, before we start, let's remember perpendicular means that means at right angles. So something like this. A line that looks going this way. Got a right angles all there, that makes it perpendicular. Okay, so perpendicular to this one with, I'm going to do the y-intercept one first. Y-intercept of 4. I'll just take that other one away. There we go. So it's going to look like, it's going to go through there and perpendicular, so something like that. Okay, So now we know what the last part is, plus 4. But the first part, it's going to slope in the other way. So it's a different gradient. So how you work it out? We take the 2, gradient of 2, and we flip it. Upside down becomes a half. But you can see this line's going down. So it's negative a half. So you change the sign as well. So that makes a perpendicular line when you flip the gradient upside down and change the sign. And there's the equation, y equals minus a half x plus 4. Okay, one more. I'll do it over here. I'll just get rid of that line. So I'm going to do a line parallel, perpendicular. To this one, but going through a point. And we'll make it there. So it's going to go through there. 6, 2. And it'll look like something like this. Okay. So what do you do? Perpendicular this time going through that point. So we have to change the gradient and the plus b. Now we know what to do with the gradient. We'll do that. Perpendicular to this line, the gradient's negative a half. We worked that out before, so that's that one there. Negative a half. And we don't know what the plus b is. Looks like it could be 5. We'll see. And I get through a point, we sub in. So y is 2 equals negative a half times 6 plus the b. So that's 2 equals negative half times 6 is negative 3 plus b. To get rid of the negative 3 from here, we add 3. That cancels the minus 3 out. 2 plus 3 is 5. I think we were right. Equals b. Yep, that's right. So the equation is negative a half x plus 5. Thanks, everyone.